In this video, we're going to go over the applications of radian measure. So the first thing we're going to talk about is arc length. And the formula for arc length is on the board right here. So it's S equals R times theta. And the thing that I want us to remember is the length of an arc on a circle is proportional to the central angle formed by the radii that intercept that arc. In other words, if I have a circle with a radius, so I'm going to highlight this in red now, and here's the angle right here that's formed. This angle is proportional to that arc length right there. So I have an example here for us, and you will have something similar to this in your homework. I took it directly from the homework. So all this is asking us to do is for an arc length S, area of a sector A, and the central angle theta of a circle of radius r, find the indicated quantity for the given values. So remember, S equals r times theta, and this is very straightforward. We're just going to make our substitutions. So S is going to equal 2.85 times 35 pi over 36. And then whenever we do this, we're just going to go ahead and simplify as far as we can. So the exact answer is going to be 2.7708 pi. So this is our exact answer. Then, if we wanted an approximation, let me write this in red. The approximation here would just be the same exact thing, except instead of writing pi, we're going to write 3.14 in that numerator. And then from here, we would just go ahead and do our multiplication, and we'd end up with approximately, let me use that notation, approximately 8.70 inches. And then, I forgot to write the units up here. This would be 2.7708 inches, or 2.7708 pi inches. And there is the difference there between the exact answer and the approximate answer. Now, if I wanted to take this one step further, I can ask for the area. So what is the area of this sector? So in order for us to find the area of this sector of a circle, we need the following formula here. So it's going to be A equals 1/2 theta times r squared. So for us, what was theta again? I forget. 35 pi over 36. So theta equals 35 pi over 36. The radius was 2.85. So this is just another direct substitution. 35 pi over 36 times 2.85 squared. So to do this problem, I'm going to need my calculator. So let's go ahead, let's get that out. I can find my mouse here, there it is. So let me minimize this. Get out the calculator here. All right, and I need that calculation right there. So I'm just going to type this all in at once. So we got 1/2 times, oops, forgot my parenthesis. So 1/2, and then we have 35 pi over 36. And then we have 2.85 squared. So the area would be 12.4. We'll just call it 12.4 square inches, because remember, area is inches squared, or better yet, square units. So the next example I'd like us to go over, and I'm going to maximize this again. We're going to talk about linear and angular velocity. So linear, write that a little cleaner, and angular velocity. So if we think about average velocity as equaling s divided by t, in other words, it's going to have some sort of speed traveled by some amount of time. All right, another way that we say this is just v equals s over t. Now, if that, I guess, projection, if you want to call it that, or if that movement is on a circular path, so I'm going to write that if moving on a circular path, we know that path is going to be the arc length, which means s equals r times theta. So what we've created now is what we call angular velocity. So angular velocity which is abbreviated with this W, okay, it's going to be nothing more than just S over T, which S is the arc length. It's going to be R times theta over T. And there is our angular velocity right there. Now, in order for us to use this formula, our units must be radians per unit time, whatever that happens to be. So in other words, we need the measurement in radians. So I have a problem here. So let me go ahead and get this ready. All right, so here's the problem here. So we have a person on a hang glider is moving in a horizontal circular arc with radius 135 meters with an angular velocity of 0.195 radians per second. What is the person's linear velocity? Well, what we know is the following. We know velocity itself is equal to the angular velocity times the radius. So all we have to do is just make our substitutions, call it a day. Very straightforward. So V is going to equal 0.195 radians per second times the radius, which is 135 meters, which means our velocity, our linear velocity is approximately 26.3 meters per second. So, like I said, very straightforward. You have one of these types of problems on your homework. So it's just a matter of just substituting it in and solving from there. The last example we're going to look at here also deals with angular velocity, but we're going to be talking about a pulley system. So the central angle corresponding to the part of a belt making contact with the larger pulley in the figure on the right is 273 degrees. Find the length of the belt in contact with the pulley if its radius is 4.10 feet. So this formula is relating the angle, radius, and arc length. So what we need is arc length right here. So we have S equals R times theta. Now, to find the values of R and theta, we're just going to substitute them into the formula. So what we know here is the radius, which I'll highlight in red. It's right here. So R is going to equal 4.10 feet. Okay? In the formula for arc length, the angle measurement, theta, must be in radians. So theta must be in radians. So we're going to convert the measured angle from degrees to radians. So convert 273 degrees into radians. Now, if you remember how to do this, we start off with the measurement, and we're going to multiply this by our conversion factor, which is going to be, in this case, pi over 180 degrees. And that's going to give us 4.76. So from here, all we have to do is just substitute theta into our formula. So even though this problem looked very difficult initially, it's actually very simple. So S is going to equal R times theta, which is going to be S equals 4.1 times 4.76, which is 19.5. And since we're measuring arc length, this is going to be feet. All right, and that's going to be it for this video. So I will see you in the next one.